Hi everybody. Today we're going to talk about chemical level. This is the first levels of organization that we will discuss based on the organizational level. So to kind of give you an idea of the components you need to know in the sense of chemistry, we're gonna introduce some vocabulary, including matter, elements, and atoms. Now, matter is, as it says, is basically anything that's around you, one, and it has two qualities. It takes up some space and it has a mass. So if we fulfill these two requirements, we consider that to be matter. Elements are basic building blocks of matter. So in many cases, if you think about periodic table represents basically the elements that form up your matter. The typical way of representing elements are using one or two letters, typically first letter capitalized, second letter if it's present, lowercase, to signify or more specifically use as a symbol for those elements. As it mentioned, carbon, for instance, will be represented by letter C. Now, if you take a look at elements, elements are made up of atoms that make up that elements. So if you say atoms of iron, they will have the same characteristics as the element iron. There is no difference. Or atoms of carbon makes up the element carbon. Now, if you guys remember, combining atoms, and I'm just kind of giving you a heads up, combination of atoms will give you molecules. And we'll discuss this as we go through the PowerPoint. If you look at atoms, there are three subatomic particles. Think about them as categories or components that make up an atom. These components include proton, which is identified as a positive charge. So I always say P for positive. Neutrons implies neutral, means no charge. So it's always represented, well, the way I represent it, it's zero with a line going through it. So the only charge that is remaining will be electrons, and that charge, it would be negative charge, and it's associated with electrons. So now that's a very basic idea. That's all you need to know for subatomic particles. Now, when we look at a setting up for an atom, let me go back to this picture. What you should notice is at the center of this atom, I will have protons and neutrons bundled up. And what you see as these blue circles, they represent your electrons that are basically forming an orbit surrounding your protons and neutrons. Electrons are going to be essential for your ability or for the atom's ability to form chemical bonds or carry out chemical reactions. So let's take a look at this. When we talk about molecules, we said molecules are basically a combination of two or more atoms, and in this case, they're held together by chemical bonds. And the way they are held together with chemical bonds is using their electrons or through the utilization of their electrons. So let's take a look at the different type of chemical bonds that are present within our environment. The first one is ionic bond. Ionic bond is the interaction that takes place between two atoms where one atom loses its electron and the second atom gains the electrons. So if you recall, the charge of electrons is negative. So if my atoms on either case started with a zero or neutral charge, now, if one of those atoms lose the electron, means they're losing a negative charge, so they become positive. The atom that is gaining the negative charge is gaining a negative charge, so they become negative. So, Loss of electron make an atom positive, and we refer to those as cation, and gain of electrons make the atom negative, and we refer to those as anions. The best example is your table salt, NaCl, where Na is positive and Cl is negative. Now we also have a scenario where your chemical bonds are formed because electrons are shared between two or more atoms. The sharing of electrons between atoms is referred to as the formation of covalent bonds. Covalent bonds. Now, if the sharing is equal between the two atoms, then there is no charge associated with the molecule. However, if the electrons are shared unequally, they spend more time around one atom, that atom becomes a slightly negative because they have more time with electron which is negatively charged. So we refer to that as a slightly negative. On the other hand, electrons are being shared by a second atom, but electrons are not spending as much time with that atom. Therefore, those are considered to be a slightly positive. The best example we always describe this concept is water. Water is made up of 2 hydrogen and 1 oxygen. In this scenario, your oxygen has more time with the electron, so it's slightly negative, and you can see the symbol for that. You can see the symbol for that right here. This is a symbol for a slightly negative. And the 2 hydrogens that are slightly positive because they spend less time with their hydrogen, and they're signified using this symbol. Now, if your atoms have a slightly positive and a slightly negative charge with them, what we describe that covalent bond, and this is something called, good thing to know, is called polar covalent bond. As in polarity, you have positive and negative charge. Now, the cells that contain polar covalent bonds can also interact with similar molecules and form something called hydrogen bonds. So hydrogen bonds, this is the keyword, guys. Attraction, it's not a full bond. Attraction of a slightly positive hydrogens and a slightly negative atoms in vicinity. For instance, if you take a look at this water molecule right here, 2 hydrogen, 1 oxygen. The oxygen is negatively charged, so it's going to interact with positive charges of neighboring hydrogen. Neighboring hydrogen, not its own hydrogen. If it's its own hydrogen, we refer to this as polar covalent bond. But if the interaction is between the opposite charges of 2 molecules, we refer to this as hydrogen bond, and this is representing an affinity, an attraction. It is not a full bond like what we see in covalent bond. These attractions are extremely important for the functionality of the water in our body and in our environment. We don't go into details about them, but you do need to know the importance of water molecule. Now, working on the same scenario, we're going to discuss the next component, which are acids and bases. You probably have heard of this. So in chemistry, you do talk about acid and base. Now, the simplified version of describing acid and bases is to start discussing water. If I break down a water molecule or dissociate the water molecule, break down or dissociate, what I will get is a hydrogen ion, H+, which we also refer to it as a proton, and hydroxyl ion, which is represented as OH negative. Notice that you have a positive and negative charge, which means at the end the charge will be neutral. So how would acid and bases differ in their concentration of hydrogen on OH negative or hydroxyl ion. When an acid breaks down or dissociates, it releases a significant amount of hydrogen. The more hydrogen it releases, the stronger that acid becomes. I'm going to repeat this. Hydrogen concentration is what determines something to be acidic. The more hydrogen you have, the stronger that acid will become. The best example for a strong acid is what you will find in your stomach, and that is called hydrochloric acid or HCl. Bases, on the other hand, when they dissociate or break down in water, they release hydroxyl ion, OH negative. Same as before, the more hydroxyl ions you have, the stronger that base becomes. Now, something good to know, bases also have low concentration of hydrogen ion because hydrogen ion is associated with acids and not bases. A really good example of a base would be NaOH, which basically is sodium hydroxide, and it's at the end of the scale when it comes to alkalinity or basicity. Now, to determine how strong an acid or base is, we use a scale referred to as pH. Notice that the lowercase p and an uppercase h. This scale ranges from 0 to 14. Number 7, that sits right in between, is considered water, which is, as we discussed, equal amount of hydrogen and equal amount of OH, hence the neutrality of water. And anything below 7, so all the way to 0, anything from 7 to 0 will be considered acidic, and anything above 7 all the way to 14 will be considered a base. Notice this, that as acid becomes again stronger, the concentration of the hydrogen will increase, and as something becomes basic, the concentration of hydrogen decreases. Here are some of the examples. It is good for you guys to understand how how each of the solutions around us fall within our pH scale. So this is kind of interesting to take a look at. Notice that within your stomach, again, you have a very strong acid because it ranges about pH of 2. I want to again highlight this component, guys, that as you move away from 7, which is neutral, if you move below 7, as you move away from it, it becomes a stronger base. So closest to 0 will be the strongest base. And as you move away from the 7, going toward the 14, you form the strongest bases. So a strongest base in our environment, as I mentioned, sodium hydroxide, would be very close to pH of 14. So I'm going to stop this lecture and we'll pick up the second part, 4 molecules of life, in the second section of chemistry of life.